Understanding the sklearn, Gaussian process, kernels exponentiation. The sklearn, Gaussian process, kernels module in scikit-learn provides a rich set of kernel functions. For Gaussian process regression GPR, exponentiation, denoted by the operator, allows you to manipulate these kernels and create more complex and flexible models. Here's a breakdown of its functionality and key points. 1. Kernel exponentiation, a flexible tool. Core principle: exponentiation in kernel functions acts as a scaling factor. It influences the smoothness and range of influence of the kernel. General form: kernel exponent. Kernel: any valid kernel function from sklearn, Gaussian process, kernels e.g. RBF, matern, dot product, etc. Exponent: a positive real number. Impact on the kernel. Exponent 1 increases the kernel's smoothness, resulting in a model that is more resistant to noise and tends to generalize better. The range of influence of the kernel decreases. Exponent 1 reduces the smoothness of the kernel. The model becomes more sensitive to noise and exhibits more local variations. The range of influence of the kernel increases. Exponent 1 no change in the original kernel's behavior. 2. Key values in the YAML configuration. Let's analyze the key values in your YAML configuration. Assuming it pertains to the sklearn, Gaussian process, kernels module. Example: YAML. YAML. Kernel. Name RBF. Length scale 1.0. Exponent 2.0. Detailed breakdown. Kernel.name specifies the base kernel function. RBF radial basis function Gaussian kernel. Commonly used for smooth and global relationships. Other possible values: matern. Dot product. Constant. White kernel. Rational quadratic. etc. Kernel. Length scale. Controls the characteristic length scale of the kernel. 1.0 in the case of the RBF kernel. This means that the model considers data points within a distance of 1.0 to be significantly correlated. Higher values lead to a broader influence of data points. Lower values result in a more localized impact. Kernel exponent determines the exponent applied to the base kernel. 2.0 The RBF kernel will be squared. This will increase its smoothness and decrease the range of influence. 3. Applications and examples. Smoothing out noise. Exponentiation can be particularly useful when dealing with noisy datasets. By increasing the exponent, you can effectively smooth out the noise and obtain a smoother model. Control of local vs. global influence. You can fine-tune the balance between local and global behavior by adjusting k. Exponent. A lower exponent allows for more local influence, capturing finer details in the data. Combining kernels. Exponentiation can be combined with other kernel operations like addition and multiplication to create even more complex and tailored models. 4. Caveats. Overfitting. While increasing the exponent can improve smoothness, it can also lead to overfitting if not carefully managed. Be cautious when dealing with complex datasets. Computational cost. Higher exponents generally increase the computational cost of fitting the model. 5. Example implementation. Python. From sklearn, Gaussian process import Gaussian process regressor. From sklearn, Gaussian process, kernels import RBF. Define the base RBF kernel. Kernel RBF length scale 1.0. Exponentiate the kernel. Kernel 2.0. Instantiate the GPR model. GPR Gaussian process regressor kernel. Conclusion. Exponentiation is a versatile tool for controlling the smoothness and range of influence of kernels. In Gaussian process regression, By understanding the principles and effects of this operation, you can effectively tailor your models for a wide range of data and tasks.